Today we shall discuss mainly about wedge constraint. That means the application of constraint motion where there will be wedges. Wedge means the inclined plane, like this. Okay, let's start with the very simple problem. This is a movable wedge on ground. This is ground, and there is a rod. This is the rod. Okay, and there is some conditions imposed on the motion of the rod. The condition is that there is a guide. This guide makes the rod move only in the vertical direction. I mean, the rod can't move this way and that way. So there, if V0 is the velocity of the rod, what will be the velocity of the wedge? If V0 is velocity of the rod, then find velocity of the wedge. This can be solved in various ways. Suppose you consider this point on the end of the rod as A and the wedge as B. Now you can apply relative motion here. That means with respect to B, if you make B as a reference frame, what is the motion of this point A? See, it can't go this way, na? Going this way means it will break the wedge and go inside it. It can neither go this way, that means it will leave contact and fly. So relative to the wedge, someone sitting on the wedge will see the point A going this way or that way. In this case it will go down, obviously, because if the wedge shifts towards the right, then it goes down, touches this point. Okay, so what we will do is that find VA with respect to B is along the incline surface, parallel to the surface of the incline. So here it is very easy to prove that. So this V0, this magnitude is V0, but it is actually VA, and this V is actually VB. So this is minus VB. So this should be the relative velocity. Simple as that. See, VA with respect to B should be in this direction. This is what its magnitude is V, but vectorially it is minus VB. See, VA minus VB is VA with respect to B. From this triangle, obviously if this angle is theta, this angle is also theta. So what is tan theta? Tan theta is V0 by V. So V is V0 by tan theta. You can try some more methods actually here. Okay. Now suppose after a certain time, this rod will come down by a distance. Here the rod will come to this point, and the wedge will have to shift like this. Obviously there is no other way. Wedge have to shift like this. So what is the displacement of the rod? Suppose this is y, and what is the displacement of the wedge? X, and this angle is theta. So y divided by x is equal to tan theta. What is y? If you take a small displacement y is equal to that V0 into t, and x equal to Vt. So there you get V0 by V equal to tan theta. So there are various ways to solve this problem, or what you can do, you can equate velocity components perpendicular to the wedge surface. That is enough, because relative velocity between A and B, or see, relative velocity of A with respect to B will be along this direction, parallel to the surface. So their perpendicular components has to be equal. So here what you can do is that this is V naught and this is V. So this is theta. So this component is V naught cos theta and this is theta. So what about this component? V sin theta. So you can equate V naught cos theta equal to V sin theta. So V naught equal to V tan theta in this way. Now what happens if a rod moves along this direction? Say rod is perpendicular and it is bound to move in this way. The rod is perpendicular to the surface of the wedge, and say if this velocity V naught and this is theta. So find velocity of the wedge. So how will you find out velocity of the wedge? What is the direction of velocity of the wedge? Obviously this way, V. Simple. What we can do, we can equate the components. This is V naught, right? It is itself perpendicular to the surface of the wedge. So what about this component? V sin theta. So simply we can equate this, na? V sin theta equal to V naught. Or else you can try out that method, that again this is A and this is B. With respect to B, obviously A will move parallel to the surface of the wedge. It will not have any of this component. So this is vector VA. Vector VA means magnitude is V naught, and this is velocity of A with respect to B. So this is minus VB and its magnitude is V. So this is theta. See, that's a right angle triangle. What is sin theta equal to? V naught by V. Same thing you are getting. You get some more problems with respect to wedges like this. Suppose this one. So this is block A and this wedge B. Movable wedge, obviously. All these are movable wedges. And this is the wall. Now this wedge moves with a velocity V naught. So find velocity of block A first relative to wedge, B second relative to ground. So it's given V naught is velocity of wedge B towards the right. Okay. So the technique to solve this problem is like this. You can observe from the wedge, right? So make this wedge B as a reference. Now I'll do in next page. So if you make wedge B as a reference, right? Now with respect to wedge B, what happens? With respect to wedge B, the wall moves with a velocity V naught. So this end of the strings moves with velocity V naught. Obviously, as the length of the string is constant, so it will move a V naught. So this is nothing but velocity of A relative to B. So therefore, velocity of A with respect to B is V naught down the incline. Now velocity of A with respect to ground is VA with respect to B plus VB. So again you have to add up this. that's V naught, angle theta, this is also V naught, but these vectors are different, right? This vector is VA with respect to B and this vector is VB. So their vector sum is what we require. So angle between these two vectors is 180 degree minus theta. So VB is root over of V naught square plus V naught square plus 2 V naught into cos 180 minus theta. So VB is this 2 V naught square minus 2 V naught square cos theta. If you want, you can simplify it. So V naught root over of 2 into 1 minus cos theta. It can be further simplified 2 sine square theta by 2. So there you get 2 here, V naught sine of theta by 2. If you have studied multiple angle and submultiple angle, then you can express it like this. Just an extension of that problem. All movable wedges, obviously. This is a wall. Wedge moves with speed V naught. Right? V naught velocity of the wedge. Now again find velocity of A with respect to B. Now that with respect to ground, you just have to add velocity of B again with that relative velocity. By the way, let's find out VA with respect to B only. So what is the way to do it? That you can make this as a frame. B is a reference frame. Wall is like a large block, right? Wall is a huge block. So this moves at speed V naught relative to wedge. So we can apply here that work done by tension, right? Or we can directly say that if these two pulleys shift by certain distance x, to keep the length of the rope constant, this will go by 2x. That means this velocity will be 2v naught because of the ratio. If this wall with respect to B, if the wall moves x, then the block A moves 2x relative to B, all relative velocities. So this ratio, that's okay, right? So that's 2v naught. Now if you at all have to find out with respect to ground, then with this 2v naught you have to add v naught, right? That's angle theta. Angle between the two vectors is 180 degree minus theta. So this would be the resultant velocity VB.